Good afternoon, good evening, good morning. This is Katannya Alven speaking to you from Canada. Beautiful sunny day. We've got some very interesting long-shaped clouds. I wonder what sort of clouds they are. Okay, I've got Bruce Lipton here, and he's in an interview with London Real. Very interesting. I'm starting at point 414, but do go, in the description box, listen to the whole thing. He's talking about, if you don't know Bruce Lipton, he's a top geneticist, and he's saying some extremely interesting things. Here we go.
Season comes every year, and I say, why is it related to the winter time?
So he's talking about the flu season comes every year.
And it's an important reason to understand that the viruses that cause the flu generally function better at lower than body temperature. So when we start breathing cold air in the winter, the respiratory tract gets cooler because of the cold temperature than the rest of the body. Well, this makes these cells in the respiratory system pretty prime for a viral infection, especially that works at lower temperatures. So flu seasons come when winter shows up, and then when winter goes away, the flu season disappears because that's not the best environment. So we're facing a flu. Now the issue is this: is it a flu? The answer, it is a flu. They want to make it so special, like, oh, it's not a flu. It's more than a flu. It's a flu. Period. That's what it's about, okay? And the relevance about that is every year we have flu season. It's every year. And I go, and I say, what about it? And I say, every year, about 0.1% of the population.
About 0.1% of the population
will die from the annual flu.
Will die from the annual flu. 0.1
every year. So why is it so different this year than in previous years? And the significance is this: the flus that come every year are really from the same types of viruses, and that previous year's flu will mutate and then show up in the next year because it's bypassed the immune system. But the point about it is this: there's an immunological memory of parts of all the different flu viruses that we've had for decades. And so when we have a regular flu, the immune system can fight it, and most people end up with coughing, sneezing, mild fever. That's the standard thing. When the immune system is working, it will easily cover it. I had a cold. That's basically what I'm saying. I say, so what's so different about this year? And I say, the virus hasn't been around for years and years. It's relatively newly introduced into the human population. So most humans do not have an immunological memory to help alleviate the symptoms of the flu. So this year the flu is a little more aggressive than previous years, only because most of us have not had an experience with this virus in the past. That's the nature of the game.
And also we have to look at where the virus was actually developed. It was developed in a laboratory.
So then I say, well, how dangerous is this flu? Well, this is the part that is really freaky.
How dangerous is the flu? If this virus was developed in a laboratory, it's interesting that actually there's a patent by the English for this flu.
Because the first thing is this: we equate the flu this season, the Corona 2019 virus, we equate it with mortality. It's like, what do you mean? I said, everyone's talking about, oh my God, we can die. And I go, well, you can die every year. That's not any different.
Exactly.
I said, so what's different? I said, it's a little more aggressive. I said, so why is it relevant? I said, okay, the symptoms are a little more aggressive. I said, well, you die from the symptoms. I say, if you have standard medical treatment, even the aggressive form that causes respiratory distress is manageable. As long as we have ventilators, as long as we have antivirals, as long as the hospital isn't under a crush, this isn't lethal. I said, yeah, but people are dying. I go, every year, the same cohort or group of people are affected and die from the flu. And I said, what cohort is that? And I said, people who, first of all, are very old, who are in nursing care, whose immune systems are already weakened just because of their age.
I'm 80, so it depends on your immune system. It depends on how well you've looked after your health. I happen to be a dancer and I happen to sing, so both those things actually help.
And secondly, those people who are already compromised, they have a problem already, whether it's a cardiovascular or cancer or diabetes, they already are compromised. These are the people who are the likely ones to succumb from this particular flu. They've always been this way. Every year, 0.1% to about 0.5% is a range. And I say, well, what about this year? They go, oh my God, 3 to 4%, which is like 30 or 40 times more lethal. I go, wait a minute, where'd you get that statistic? The way you get the statistic is you take the number of people who died and divide it by the number of people who have the virus. I go, okay. So I said, well, what's wrong here? And I'll tell you what's wrong is when they've tested like a whole city, like in Idlib, in Idlib, for example, they tested the population and they found that more than half of the people that have the so-called COVID-19 virus, more than half of them have no symptoms at all. I say, so why is that relevant? I say, if you take all the people who have the virus, whether they have no symptoms or whether they have symptoms, that's a very large number compared to the number of people who went to the doctor and got reported to have a virus. So I say, why is it relevant? I say, if you take the very large number of people who have been exposed and who have that virus, and then divide that into the number of deaths, guess what? It's not 3 to 4% at all.
Okay. Did you hear him say that? It's not 3 to 4% at all.
It's below 1%.
It's below 1%, which I think he said earlier ties in with that's the normal amount of people who are dying per year.
So, well, now you're in the range of a normal flu.
That's right. Now you're in the range of a normal flu, which only comes in the winter or the cold weather.
I go, well, yeah, exactly. But the fear that has been generated.
The fear that has been generated
by this is the biggest problem of all, because people have to understand about the immune system.
This is the important bit. The fear affects the immune system. Now, fear, an acronym, can be false evidence appearing real. False evidence appearing real. Fear. Interesting. When you watch television, and I happen to pass through when my daughter's watching television, and I don't basically watch it. It's all about fear-mongering. It's all about the devastating effect of coronavirus, etc. It's all fear porn. That's what I call it, and a lot of other people call it too.
The immune system is designed for internal protection. Anything that gets in my body, parasites, viruses, bacteria, the immune system's function is to fight that. And I say, does it use energy to have the immune system? I go, of course. If you've ever been really sick, you probably didn't have enough energy to get out of bed sometimes. I say, the immune system uses lots of energy. I go, so what?
He says the immune system uses lots of energy. If you go on to my website, which is in the description box, moreenergyforlife.com, you will see that I use an energy device called the scanner. and I'll show it to you on another video. And there you can have a look at what the scanner is.
Well, then here comes the problem. There are two protection systems. The immune system protects me on the inside. The adrenal system, which is called fight or flight, protects me from threats on the outside.
Exactly.
I go, so why is it relevant? Well, let's give a scenario here. You have a bacterial infection. You might have a bad case of diarrhea coming. And you're being chased by a saber-toothed tiger.
Oh my God!
Question, if I had to divide the energy in my body to protect me from the flu or bacteria and from the tiger, how would you split the energy distribution between those two? And Brian, this is really relevant. I mean, ask you, if you're being chased by a tiger, you got a flu, what proportion of the energy of your body do you want to use to run away from the tiger, and what proportion do you want to use to fight the bacteria? It's a pretty clear answer, I hope.
Exactly. We'd use it in our arms and legs to run.
I hope you see it.
Or climb a tree.
Probably 99 to 1 is probably what I would say.
Exactly. So right away, that's the fundamental principle. Fundamental principle is this. I distribute energy in the body where I need the energy. And when it comes to threats and survival, if it's a threat from the outside world, I need to put all the energy into that. So I say, fine. I say, how does this work? I say, when we perceive a threat,
when we perceive a threat, remember the acronym? Fear, false evidence appearing real. Now, sometimes you are and you do need to take action because there is reason to be fearful, but you have to make the choice.
Believe and perceive that we're being chased by that saber-toothed tiger. The body releases stress hormones. I go, yeah, so what? That gets me ready. I say, gets you ready for fight or flight. I said, what does it do to get you ready? And this is the crux of the problem. The stress hormones do is take the energy of the body, stop funding with energy those functions that are not necessary to run away from the tiger. Because what you want to do is you want to get all the energy possible into the arms and legs, which is the blood. The blood carries the energy. I want all the blood in my arms and legs. Why? Because I need to run away from that tiger. So I say, so what happens when stress hormones are released in the body? And the first thing is this, all functions not related to running away from that tiger are shut down to conserve the energy. So I said, well, what does that mean? I say, when stress hormones are released into the body, they...
That's really interesting. Think about that as an analogy, that when there is that tiger, the thought of that tiger or the fact of that tiger coming, the body automatically shuts down the blood to anywhere that isn't necessary. So the blood goes into the legs and the arms for running. Interesting. Think about what has happened to the world. It's actually been paralyzed and it can't run.
Cause the blood vessels in the gut to squeeze shut. I go, why? And the answer is, if the blood vessels squeeze shut, then the blood is pushed to the periphery, the arms and legs. So the blood is, in scientific terms, preferentially sent to the arms and legs at the expense of what? Shutting the blood vessels in the gut. And that's when people get butterflies in the stomach. When they start to get scared, they can feel a little queasy going on. And I say, what is that? I say, that's the action of stress hormones causing your blood vessels in the gut to squeeze shut, so you push the blood to the arms and legs to deal with fight or flight. Okay, so the first thing is this. When you're in fear, you shut down the growth and maintenance of the body.
Okay, when you're in fear, you shut down the growth and maintenance of the body. And it was Prince Philip that is quoted, if I have a chance of coming back, I would come back as a deadly virus to depopulate. He was inferring, or might have said, to depopulate the planet, okay?
It's very simple. Why should I fund those things if the tiger's chasing me? If the tiger catches me, then maintenance of the body is not my problem anymore.
The tiger's got him.
So the first step in a stress response is stress hormones shut down the visceral functions of maintaining the body, filtering, cleaning, repairing, replacing things. I go, okay, that shuts down